Hi, today we're going to look at problem 1 from the 2019 AP Statistics exam. Usually problem 1s are just about describing distributions of single variables or very basic linear regression questions, usually pretty simple. So let's take a look at what this one's asking. It says to us here, the sizes in square feet of 20 rooms in a student residence hall of a student university are summarized in the following histogram. And then there's this innocent little question in question A. It says, based on the histogram, write a few sentences describing the distribution. So when you see those words describing the distributions, there's plenty of ways to remember what you should address. One thing you should definitely address is the shape of the distribution. So you should say, what can you say about the shape here? So I would say that it's approximately symmetric for sure. You can see sort of like a line of symmetry down the middle, sort of mirror reflections there, so it's symmetric. But I would also go on to say that it's a good word to use here would be bimodal. Mode, in case you forgot, is the most occurring element in a data set, and it looks like we have two bars here that are really tall and much bigger than the heights of the other bars. So we say that most of the data falls between, say, 150 and 200 square feet of room size, or the other big chunk of data seems to fall between 250 and 300. You can see those intervals right here on the bottom. So you'd want to mention that when you start describing the shape. There's a popular trick called SOCS as an acronym to help you, or a mnemonic device, we'll say, I don't know, to help you remember things. SOCS, shape, outlier, center, and spread. We've addressed shape. Outliers, it doesn't look like there's any data that's really far away from the rest of the data. Like if this graph continued, for example, and I had a big bar out here somewhere, then I might say, hey, you know what, this data over here is an outlier. But that's not happening. So I'm going to say that there's probably no outliers. So that takes care of outliers. Talk about shape and outliers. In terms of the center, it looks like the center is somewhere, since it's nice and symmetric, you'd expect it to be right in the middle. So we might say that the center is between 250 and 300 square feet. And then lastly, I want to talk about spread. So when you're talking about spread, there's a couple ways to remember. One thing you might want to talk about is range. Maybe a reasonable thing to mention here. You can say that the size of the room range from, say, about 100 square feet all the way up to 350 square feet, or total range. Total range is, by definition, is usually max minus min. So you might want to say it's approximately 250, but even there's no guarantee, because with histograms, if we look at this bar here, this bar I'm underlining and outlined in red, this first bar, that means there's 3 rooms, because that's the height, right? There's 3 rooms between 150 and 100 square feet in floor size. And so it might be the case that all 3 of those rooms are just 100 square feet, or it might be all 3 of those rooms are 148 square feet. So we don't really know that there's a data point at 100. We just know that's where the histogram sort of starts. So I suppose we could be a little more precise here. What we could say is the maximum range is somewhere, can go from 100 to 350. So 250 would be the maximum range. And then if we were to consider the minimum range, that would be, say, from like 150 up to 300. So you could say 150 is your min range. Tough to see that yellow. But that would probably be the most precise answer. Either way, we've addressed all of the 4 things: the shape, the outlier, center, and spread. And if you do all that, then you're pretty sure you have a comprehensive answer to describing a distribution problem. Okay, let's copy this for a second. Let's go to another page here and paste this. There it is. So we have in part B, it says we're given some summary statistics. So you can see them all. Oops, sorry about that. You can see them all right here. There they are, right? And so part B, the actual question they're asking is here, determine whether there are any potential outliers for the data, and then provide a sketch of a box plot. Okay, so we need to check for outliers. So there's a nice mathematical check that says the following. X is an outlier if X is less than Q1 minus 1.5 times IQR. In case you forgot, Q1 stands for quartile 1, which is the data point in this set where approximately 25% of the data is below it. And IQR stands for interquartile range. To compute the interquartile range, IQR, you just do Q3 minus Q1. There's a second thing that could happen though. X could, like we said, could be less than Q1 minus 1.5 times the IQR. If that happens, you know X is an outlier. Or if X is greater than Q3 plus 1.5 times the interquartile range, or IQR, then it's also an outlier. So we have all the numbers here to actually check this computation. We can check and see if this stuff is really happening. So let's go to a new page. We're going to use these rules here. I'm going to use these rules and check and see if any outliers are present. So we'll go to a new page again because I wrote all over that one. Here it is. And so here we go. So here, the IQR, if we go to compute that, would just be 292 minus Q1. So this is Q3, here's Q1, minus 174. So we need to subtract those numbers. So let's see, 292 minus 174, we're getting 118. And while we're at it, let's do 1.5 times the IQR, or 1.5 times 118. So if we do that, we end up getting about 170, well, exactly 177. So I'm going to do Q1 minus that. So Q1 is 174 minus 177 is negative 3. So we would need an X value to be less than negative 3. Now, if we look at the data here, we notice the minimum is 134. So that's letting us know that there's no way that there is a low outlier, because to be a low outlier, we would have needed X to be less than negative 3, which is not happening. Okay, let's check on the high end, Q3, so 292 plus 1.5 times the IQR plus that 177. So if we add those together, I'm getting 469. And we can see in the table that the maximum number you have there is 315. X would need to have been bigger than 469 to be a high outlier. So that means we don't have any high outliers. All right, so no outliers means that we're ready to do a box plot. That's what this question asked. It wanted us to make a box plot here. And so if we go back, the box plot always has in it, has the minimum Q1, the median Q3, and the maximum marked off. So I will do this. I'll flip back and forth from page to page. The minimum here I circled in red is 134. So I go where I think 134 is, and I'm just going to put a, I don't know, a vertical line like that maybe. Okay, so that's corresponding to 134. If I go to the next thing, Q1 is 174. So I'll go to where I think 174 is. It's probably here. And it's customary to make that bar a little, that little line a little longer. There it is, 174. What else do we have? The median is 253.5. So 253 is probably about there. 253.5. Certainly can't be exact. Q3 is 292. So that's going to be pretty close to 300. It'll be up here. That's 292. And then lastly, the maximum is 315. So 315 is probably over here somewhere. And make this last thing about the same size as the first one that was over on the left. And then the customary thing to do is you put a box to indicate the middle 50% of data, you're going from Q1 to Q3. Let's erase that. I got a little sloppy. Sorry about that. To Q3. And then we put little lines going out to the side like this and this. And this is the min, and this is the max. And it's very important that you know that this is the median in the middle. It's not the mean. Okay, and then finally we're finished off by asking what characteristic of the shape of the distribution of room size is apparent from the histogram, not from the box plot. So when we look at this box plot, it looks pretty symmetric. Someone might say, D, it looks a little skewed left. You notice that like this is a little longer than this. When I said, hey, D, that's what people call me when they talk to me in person. Sometimes instead of saying D Marinas, they say D. Okay. Anyway, so you might say this looks a little bit skewed left. What it definitely doesn't look like, though, is this picture where you can clearly see the bimodal nature of the graph. You can see you've got these data sets here, right? These parts of the data set that are really high. And you don't see that in a box plot. So that's just one of the points of this question, is to sort of compare different ways of representing data and sort of understand what the limitations are. Sometimes you're limited by, what type of graph